Today we're going to learn about solving rational equations. And the idea of being able to solve rational equations is that you want to get the denominators to be equal on both sides of the equation. So if your denominators are equal, then what you'll have is this. Get those denominators to be equal. And then you can set your numerators equal to one another and solve. So that's the goal. So we're going to use what we've already learned about adding and subtracting rational functions by finding that least common denominator, or LCM, however you want to look at it, and solve these equations. So we're going to start off in this first one, and we want to find what the least common denominator is because we need those to be equal. So I know I'm going to have x plus 3 is going to be one of my factors. And then if you notice, I have a 6 and I have an 18. And I'm looking for the smallest number that they both go into. And this one's kind of nice because 6 does go into 18. So that means 18 is my coefficient here that will be a part of my LCD. And then from there, I'm going to multiply each numerator by whatever I don't have in my denominator. So on this first one, I'm still missing, I have the x plus 3, I'm missing this 18. So I'm going to multiply this numerator by 18. Over here, I need to multiply by 3 to get to 18, and then also that x plus 3. And then here, I have the 18, but I don't have the x plus 3. So now I'm going to rewrite this whole thing. So I'm going to have 72 over, and remember you're doing the bottom by this as well. I guess I'm not showing that, but let me just show it so we can make sure we're all doing the same thing. Okay? So I would have 72 over 18 times x plus 3 plus 15 times x plus 3 over 18 times x plus 3 is equal to 23 times x plus 3 over 18 times x plus 3. And then I'm going to go ahead and simplify that even more. So I'm going to go ahead and take this 15 through. So that's 15x plus 45. I'm going to take this one through. That's 23x plus 69. And then I have this 72 that I'm going to bring down. Okay? And all of this, so I could write this side just as 1, right? Over this. And so what I can do is I can drop those denominators and I can set those numerators equal to one another. And then we're going to solve it. So I'm going to combine like terms. So 72 and 45 is 117. And then we're going to, I'm going to subtract 15x on both sides. Then I'm going to subtract 69 on both sides. So 48 would equal 8x. And so I know x equals 6. And then I do have to check because remember we can't have 0 in the denominator, right? Because that doesn't work. And so if you check here, I'm just going to go over here. If I plug in a 6, this denominator would be a 9. These denominators are already numbers, and so I am good. So the check doesn't require a lot, just double checking to make sure you've got it. All right, there's our first one. So let's try our second one here. Okay, so on this one, let's go ahead and erase. If you look here, I know that that's a difference of squares. So I'm going to write that as x minus 1 times x plus 1. And I'm going to get rid of that. So now I want to find that least common denominator where I'm writing all the factors. So our factors are x plus 1 and x minus 1. And that's going to be it. So I'm going to go up and I'm going to multiply by what's missing. So this one I'm going to multiply x minus 1 top and bottom. This side I'm going to multiply by x plus 1 top and bottom. And on the right side there's nothing to multiply by because I already have it. So now I'm going to rewrite. So I have 2 times x minus 1 minus 1 times x plus 1, equals negative 2. And then that's going to be over, so I'm going to put this all together here, x plus 1 and x minus 1 on both sides. Okay, and then I'm going to go ahead and distribute through. So 2x minus 2, this is a negative 1 that I'm distributing through. Negative 1x minus 1 equals negative 2. And I'm going to go ahead now and just skip the step of rewriting the denominator. I'm going to drop it. And then I'm going to combine like terms. So 2x minus x is x. Minus 2 minus 1 is minus 3. And when I solve that, x equals 1. And then we're going to check. And so if I plug in a 1 here, that denominator would become a 2. That's fine. If I plug in a 1 here, that denominator would become a 0, and that cannot work. So that answer doesn't work. So my answer is actually no solution. Will be my answer. Okay? All right, next example. Okay. So I'm going to take my trinomial here and I'm going to factor that, and that can be shortcut factoring. So we're looking for factors of 15 that add to 8. So that would be a plus 5 and a plus 3. So this would become x plus 5 and x plus 3. So I'm going to mark this out because that's my new denominator. I'm going to erase this. Okay, so my least common denominator is x plus 5, and then my other one is x plus 3. So if you'll notice, this one was already nothing to do. So that was x plus 5. Over here, I already had the x plus 5 written. I need to bring in the x plus 3. And then over here, I already have that x plus 3. So it's just going to be this. So I'm going to go through and write what I need to multiply by. And I'm not going to show it top and bottom. I'm going to assume that we all know that by now. Nothing to do on the second one. And then x plus 5 on the bottom. Okay, so let's go ahead and rewrite. So I have 2x times x plus 3. And what I want us to pay attention to on this one is this is a minus sign, and that's a trinomial. So I need to subtract off every part of that trinomial. So that's going to be a minus x squared, a positive x, and a positive 10. And then that's going to equal 3 times x plus 5. And then my denominator over here is x plus 5 times x plus 3. And over here, x plus 5 times x plus 3. And then we're going to go ahead and simplify this. So when I multiply that through, that's 2x squared plus 6x. When I do it here, that's 3x plus 15. Oops, lost that. There we go. And then I'm going to rewrite the rest of this. This minus x squared plus x plus 10. I'm going to drop the denominators because those denominators are equal. So I'm just going to set my numerators equal to each other. And I'm going to combine like terms here. So 2x squared minus x squared is x squared. 6x plus x is 7x plus 7x. And then I have this plus 10 equals 3x plus 15. And it looks like This is going to be a trinomial because I have a squared, an x, and a constant. So I'm going to get this equal to 0. So I'm going to subtract this over. And so that would give me x squared plus 4x minus 5 is equal to 0. So now I'm looking for factors of -5 that add to +4. And that would be a +5 and a -1. So I can do shortcut factoring. So x plus 5 and x minus 1. And then this is that zero product property. So remember, we're going to separate and set equal to 0. So one answer would be -5, and the other answer would be +1. And now we need to check. Okay, so I'm going to start with -5. If I plug in a -5 here, that denominator is going to become a 0. So I know that this one is out. If I plug in a +1, this denominator is a 6. That is fine. If I plug in a 1 here, that's a 6. That's a 4, which is a +24. That's fine. And then if I plug in a 1 here, that's a 4, and that's also fine. So this one does check. And so my final answer is just x equals 1. Okay, let's look at the next example. A little too far here, hold on. Okay, so the next example, so first thing I need to do is find that LCD, which I need to take out simplify any denominators that I can. So here I see a 3. I'm going to take that out. Here I see a 4. I'm going to take that out. And here I see a 2. I'm going to take that out. Okay. So now, when I'm finding, I'm going to do it over here, that least common denominator. Remember that a 4 is a 2 and a 2. So I have a 3, and I have 2 2's. And then I have a 2 here, but I already have a 2 written, so I don't need to write it twice. So this becomes 3 times 6 times 2 is a 12. And then I'm going to write the other factors, which would be n plus 1 on the first one. The second one has an n minus 1. And then the last one has an n plus 1, which was already written. So this is my least common denominator. So I'm going to multiply each fraction by what is missing. So the first one is missing, I need a 4 to get to a 12, and then n minus 1. The second one, I need to multiply by 3 to get to a 12, and an n plus 1. And the last one, I need to multiply by a 6, and an n minus 1. Okay, so we are going to rewrite. So I'm going to rewrite this as 28n times n minus 1 minus 15 times n plus 1 equals 18n times n minus 1. And this is over 12 times n plus 1 times n minus 1 on both sides. And then we're going to start simplifying. So I'm going to multiply through here. So 28n squared minus 28n. Then I'm taking a -15 through. So -15n minus 15. And then that's equal to, and then I'm going to multiply through here, 18n squared minus 18n. And then I'm going to combine these two together. So 28n squared minus, what is that? 43n minus 15 equals 18n squared minus 18n. And then I'm going to get this equal to 0. So I'm going to take these over. So I would have 10n squared minus 25n minus 15 is equal to 0. And then I noticed that this trinomial, they all have a 5 in common. So I'm going to take that 5 out. So that would be 2n squared minus 5n minus 3 equals 0. And then since I'm solving, I can go ahead and get rid of that coefficient out front, because 0 divided by any number is just 0. So that would be 2n squared minus 5n minus 3 is equal to 0. So now we are looking for factors of -6 that add to -5. Factors of -6 that add to -5. So that is going to be a -6 and a +1. And just as a reminder, you can't use -3 and -2 because that multiplies to give you a +6, and we want it to be a -6. Okay? I can't do shortcut, so I'm just going to take this and I'm replacing this with my factors, that -6n plus 1n. I'm going to rewrite the others here. 2n squared minus 3 equals 0. Then we're going to group them, then take out a GCF. So from the first group, I'm going to take out a 2n, and what's left would be n minus 3. Out of the second group, they have a 1 in common, and what's left would be n minus 3. And so I have n minus 3 times what's left over, that 2n and that +1. And then I'm going to separate and set equal to 0. So n equals 3. And then my other answer, subtract 1, divide by 2. N equals -1/2. Okay, so we're going to now check. I just want to make sure these are going to work. So if I start with 3, if I plug in a 3 here, that's a 4, so that's going to give me not a 0. If I plug in a 3 here, that's a 2, not a 0. Plug in a 3 here, that's a 4, not a 0. So I know that n equals 3 works. So 3 checked. Now I'm checking -1/2. So if I take -1/2 and I plug it in, that's not going to give me a 0. Doesn't give me a 0 here. Doesn't give me a 0 here. So -1/2 also checks. So this answer, this rational equation had 2 solutions, -1/2 and +3. Last example that we're going to look at. Okay, so we're going to start. We got to figure out what this least common denominator would be. And if you notice, I have this trinomial here that I need to factor. So I'm looking for factors of -8 that add to +2. And I can do shortcut on this one. So they add to +2, so it's going to be a 4 and a 2. And this 2 is going to be the negative. So it would be p plus 4, p minus 2. And then I can mark that out there. Okay, so my factors would be, I see a p minus 2. So I'm going to write that down. And then over here, I see a p minus 2, which is already written. But I have this p plus 4 that I need to write. And then on this denominator, I have a p plus 4, which we already have. So my LCD is p minus 2 and p plus 4. So now I'm going to go through and multiply by what I would still have left. This one, nothing. And this one, p minus 2. Okay, so we're going to write, I have 1 times p plus 4, which is just p plus 4. And this one's just 2p plus 1 plus 2 times p minus 2. My denominator is p minus 2 times p plus 4. And then I'm going to go ahead and take this 2 through, which would be 2p minus 4. And then I'm going to bring down the rest of this. Combine like terms. 2p and 2p is 4p. 1 and -4 is -3. And then we're going to solve. So I'm going to subtract p on both sides, and I'm going to add 3. So 7 equals 3p. So p equals, I'm going to leave it as a fraction, 7/3. And then I'm going to check that. So if I plug in 7/3 here, that's not going to give me a 0. If I plug it in here, not a 0, not a 0, not a 0. So all you're checking is if it doesn't equal 0, then you are good. And my answer is p equals 7/3. Your homework assignment is to do 16 through 21 and number 34 on page 577. If you have questions, please write it on your discussion board.